Module 5, Lesson 2 is about function notation, and it's actually an introduction to functions. A function is the set of ordered pairs in which each x-coordinate has exactly one y-coordinate. So every equation that we have is a relation, but not necessarily a function, and then we'll talk about that in a minute. So there's two other terms that we're going to talk about with function, domain and range. Domain are the set of all x values, and the range is the set of all y values. So let's take a look at number 1a. So we have an x values and the y values. So the 2 maps to a value of 5. Negative 2 maps to a value of 4. And then 2, 0 also maps to a value of 0. So the 2 maps to two different things. No, this is not a function. Because for the value of 2, I have two different y values. However, I can still list the domain. The domain is 2, negative 2. And the range has three values, 0, 4, and 5. And I really don't care if you list them in order, but I do care if you put the squiggly brackets. They have to be squiggly. Don't use parentheses because it could be construed as an ordered pair. Do not want to use those regular parentheses. Okay, let's do the next one. 0 maps to 0, we're okay there. Negative 2 maps to 4, we're okay there. And 2 maps to 4. And I'm okay with that because each x value maps to exactly one y value. In other words, the x values in a function really can't repeat to get two different y values, okay? But the y values can repeat as long as my x values are all different. So yes, this is a function. My domain is 0, negative 2, 2, squiggly, squiggly. Range is 0, 4. I don't have to list the repeated values. Here. Now, from the other example, if I want to graph the points, I wrote the actual points here so that we would be able to recall them from the other example. So let's graph 2, 5, negative 2, 4, and 2, 0. Okay. You'll notice that these 2 points here, 2, 5 and 2, 0, are stacked. So anytime we have any kind of stacking going on, it's not good, all right? Now let's do the other one. So if 2 points are stacked, it's not a function. Here are the points for part B, 0, 0, negative 2, 4, and 2, 4. These are side by side. Side by side is okay. Stacked is not good. So this is a function. No stacking. Let's try that again. No stacking. If there's stacking, it's not a function. Let's do this. Stacking is not good. There we go. Next slide. All right, now it's beautiful if they give you a graph, you can immediately tell whether it's a function or not by using the vertical line test. If I draw a vertical line and I only hit the function at most once, it's a function, okay? Or if I only hit the graph at most once, it's a function. In other words, there's no stacking going on here, so there's a function. The only lines that are not functions are actual vertical lines, because then they're stacked all the way down. B here, oh, I have stacking going on because this x value has two distinct y values. This is not a function. So I love the vertical line test. If it hits the graph a couple of times in one space like this, look at that. You can see stacking is going on. Stacking bad. Okay, great. Now, what else do we have to determine in this problem? The domain and the range. Well, for lines, the domain here is all reals. And the range here is also all reals. Okay? Now for B here, we have to determine the domain. And we have to think about the x values that we don't see. Okay? So if I look at -10, -10 doesn't have any values at all for the graph. I see that we start to have values when x is -6. So x needs to be greater than or equal to -6 for the domain. For the range, well, if you think about it, these guys could end here, but they could go on forever and ever. So let's assume that it's going on forever and ever. So this sideways parabola is going to widen, widen, widen. So for the range, it's all reals. Okay. Next slide. Okay, now we have algebraic representations for functions, and I just love this representation. Here's my function value. And this says f of x equals x minus 7. And I'm going to try to convince you the beauty of this notation. So let's look at 4a. This says to put 3 in for everywhere I see an x. So f of 3 is equal to -4. That means the value of the function at x equals 3 is 4. So, -4. Okay, so here's the deal. We can see the input, and then we can also see the output. Nice, right? So let's do the same work on this function. F of -1 is equal to -1 minus 7. So f of -1 equals -8. My input's -1, my output's -8. The x value is -1. The y value that comes out is -8. So I would actually, if I were to graph this point, it would be -1 comma -8. Well, f of 0. I'm going to put 0 in everywhere I see an x. So f of 0 is equal to -7. What's the beauty of it? We can see both the input and the resulting output from that input. Last but not least, let's do a little bit more challenging one. F of x is equal to 10 take away x squared. I'm going to pop in 1 for x. Notice how I put parentheses around the 1 as I plug it in. So f of 1 is equal to 10 take away 1, because 1 squared is 1, is 9. So f of 1 equals 9. And last but not least, f of negative 5. It's not as important to put the parentheses with positive numbers because you can't mess up as much, but with negatives you can totally mess up. So this is 10, take away 25, because negative 5 squared is 25, so it's a negative 15. So f at negative 5 equals negative 15. Yay! Now you can start the written assignment for this and then go into the My Math Lab assignment. Good luck, and ask questions as you need to.